Hello, this is Mrs. Pullen for Lesson 2.04 for AP Statistics. In this video, I'm going to show you how to find areas under the normal curve using a standard normal table. We use a standard normal table because we can't use the empirical rule for values that are non-integers. So what is a standard normal distribution? It is a distribution whose mean is 0 and a standard deviation of 1. And instead of looking at x values, we say we're looking at z values for the z-score. So let me just get this pen out. So z is from a normal model with a mean of 0 and a standard deviation of 1. So this is a portion of Table A. Where can you find Table A? Well, that's that special handout that I gave. So I gave you a formula sheet that's provided on every AP exam, and I'll provide you a copy on every test. So the first page are formulas that you're going to be using in other units. The second page are formulas you're going to be using on other units. And if you look at page 3 and 4 of your reference sheet, this is the normal distribution when you have negative z-scores. Notice this is a normal curve, and when they're giving these proportion of datas, you're always looking to the left of whatever that cutoff point is. So suppose, just so I make sure everybody understands, suppose I was looking at the probability, and this is not going to let me write on it, this particular document. Actually, I should be able to. If I want to find the probability that z is less than negative 2.85, I would go to negative 2.8 on the left side of the table, and I would scroll over until I found a column heading of 0.05, and in this case it's 0.0022. So that's how you would use Table A, and page 4 are positive z-score values, so the same thing. Notice you're still looking towards the left, and notice the values are now positive, but it's that same principle. So if I'm looking for a z-score, if this z-score is 1.1, and I wanted to find the probability that my z-score values are less than 1.1, I would go to 1.1, and in this case it's 0, and I would get 0.8643. Okay? I'm going to erase that now because I'm going to need this in a moment. And let me go ahead and erase the other writing. And again, the area is always to the left of that curve. Okay, so back to the problem. So we want to find the proportion of observation from a standard normal model, and that just means that the mean is 0 and the standard deviation is 1 when the data values are less than 0.81. So in this case, since your mean is 0 and your standard deviation is 1, instead of x values, you would use z. So z is less than 0.81. And this notation is required. So 0.81 is about here, and for all the problems you do in the homework, I will only give you credit if you draw the normal curve and shade it properly. So here's my mean of 0, here's the 0.81. You would shade it. And now I'm going to show you how to read the table. So 0.8 is the 10th place, and we want 0.81. So you would go to the column that says 0.81, and that intersected value is the proportion of data. So 0.791 is that shaded region. Example 2. After accelerating for 20 seconds, the DeLorean sports car has a wide range of speeds that can achieve, depending on traction. The distribution of speed follows an approximately normal distribution with a mean of 80 and a standard deviation of 7.7 miles per hour. So here's that shorthand notation that I went over the other day. Okay. And the first thing they want you to do is label the values on the normal curve. Now remember, I gave it to you in your notes, but for homework, you're going to have to draw that normal model. So here's 80, and a score 7.77 miles per hour above would be 87.7, and 2 standard deviations, you would add another 7.7 to get 95.4, and then you would add another 7.7 to get 101.3. And now you want to go 7.7 standard deviations below, and you get 72.3, and another 7.7, and you get 64.6, and another 7.7, and you get 56.9. Okay? So we just labeled this distribution. And these are the actual C-score values. So if you're at 72.3 miles per hour, you actually have a standard deviation. You actually have a data value that's 1 standard deviation below the mean. So now I ask, what percentage of runs will give you a DeLorean speed that's less than 68.45? Well, unlike the problems we did yesterday, it's not falling on an integer value. And for today's lesson, you must use Table A. Tomorrow I'll show you how to use the calculator and my expectations of the work, but today you're going to use Table A. So Z is equal, so our X value is 68.45, and we actually have to convert it to a Z-score. So the Z-score formula is X minus mu over sigma. So Z is equal 68.45 minus the mean of 80 over the standard deviation of 7.7. And when you enter that in the calculator, you get a value, a Z-score of negative 1.5. So before I continue, for every normal curve, for every problem from this point forth that deals with the normal distribution, you're going to make a bell curve and you're going to put the mean in the middle. So in this case, it's 80, and we're looking for a data value that's 68.45. So any value that's less than or equal to that. So you draw that in, and then you must shade it. So we're going to shade this way, and let's continue. So the notation you're going to use, in this case, you took your original data value and you said it was less than 68.45, and you converted that to a Z-score, so the probability that Z is less than or equal to, actually it's just less than in this case, negative 1.5. And you must write it like this. This is my expectation of what you're going to put on the test. And if you don't, you'll lose points. I can't be any more clear of what I want. Okay, so now you're going to go to Table A, and we want to find negative 1.5. So we go to the table, and this is page 3, and we see negative 1.5, and in this case there's no hundredths place, so it's just 0.0, it's right here, 0.0668. And we need to convert this to a percent because that's what they asked for, so you multiply it by 100, and it would end up being your final answer, 6.68%. And so that would be the answer to part B. Whoop, that's not what I want. I want the highlighter. Okay, part C. What percentage of the runs will give the DeLorean a speed greater than 85 miles per hour? So we first start off by making a bell curve. Hold on. Here's 80. 85 miles per hour would be above 80. And now we're going to shade. And again, you must draw a sketch with the shading. So we want to find the probability that x is greater than 85. So before we continue, what you have to do is find the z-score. So we're going to substitute into the formula. So it's the data value x minus the mean of 80 over 7.7. And when you do that, you get a z-score of 0.65. So we want to find the probability that a randomly selected run is greater than 85 miles per hour, which is equivalent to the probability that z is greater than 0.65. Now, before we go to table Z, what's different about this, if you recall, the proportions that are shown in table C are always to the left of the data set. Let me just show you what I mean. So we're going to go to the table, and we want to go to 0.65, so that's on page 4, right? Those are the positive values. So here's 0.6, and if you scroll to 0.65, okay, here it is, and above is the 0.05, that's 0.7422. But that's not the answer, because the 0.7422 represents this gray area. We want above. But since we know that the whole area of a normal curve sums to 1, to get the area above, it would be 1 minus 0.7422. Okay? So let's go back. So this is the same thing as 1 minus the probability that z is less than 0.65, which is the same thing as 1 minus 0.7422, as I just showed you, and that ends up equaling to 0.2578, or 25.78%. Part D, just a little bit more. What percentage of the runs will give the DeLorean a speed between 64.6 and 87.7? So again, you're going to mark up your diagram. Here's 80. Here's 64.4, and this is 87.7. So we're looking for this area here. So that's the same thing as the probability that you're between 64.6 is less than or equal to x is less than or equal to 87.7. So we're going to find the z-score of both of those. So z is equal to 64.6 minus 80 over 7.7. And when you do that, you get -2. And here z is equal to 87.7 over minus 80, hold on, over 7.7, and that's equal to 1. So really what you're trying to do is find the probability that your data value is in between -2, and notice you're converting it to a z-score, and 1. Okay, so that's 0, -2, 1. Now you could do this from table Z, but here's a little trick. When you're looking at the interval between the two values, how do you get that shaded region? What you have to do is you find the probability that Z is less than 1. Okay, so less than 1 is everything. Like that would be, you know, here, 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 everything below. So we're kind of overshooting it. And then what you're going to do is you're going to subtract off the probability that Z is less than -2. So that area here, you're now subtracting off. And when you do that, you're getting the proportion of data in between those two. So you're taking the high z-score minus the lowest z-score. So what's the probability Z is less than 1? We go back to table A. So where is 1? 1 is here, and that's 0.8413 right here. Minus Z is less than -2. So let's go to -2, that's on this page. So -2 is right here, so that's 0.0228. And when you do that, you get 0.8185 or 81.85%. Okay, 2 more problems. What percentage of runs will give the DeLorean speed between 70 and 95? So again, you're going to make your normal curve. I was gracious to do it on your note packet, but you're going to have to do it for every problem. And then you're going to shade, and you make a nice, pretty normal curve. Don't make them sloppy. So we want to find the probability your data values are between 70 and 95. So we're going to convert them into z-scores. So 70 minus 80 over 7.7. And when you do that, you get -1.3. And now you're going to get the z here. And that's going to be 95 minus 80 over 7.7. And when you do that, you get a value of 1.95. So this original probability is equivalent to your z value being between -1.3 and, notice I converted it to a z because that's a z-score, and 1.95. So if you want to get the area in between two values, you're going to take the probability of the largest, so that highest value, and you're going to subtract the probability of the lowest value. And this is the exact notation. If you're confused by it, certainly come to see me at Extra Help. Okay, so let's go for it. So we look for 1.95. So go to the row 1.9 and like 0, 1, 2, 3, 4, 5. So that's down in this column, and 1 point, and that's 0.0256. Oh no, that is not, I'm in the negative area, that's why. Hold on, here we go. I knew something didn't seem right. So 1.95, so here's 1.9, And 1.95, that's 0, 1, 2, 3, 4, 5, that's 0.9744. Minus, now we go to the negative area. So negative 1.3, and that's 0.0968. And when you do the arithmetic, you get 0.8776 or 87.76%. And one last problem. If Marty wants his last run to be at the top 10% of all speeds, what speed does he need to achieve to be in that top 15%? So we're going to change this problem to the top 15%. So if we could just make that correction. So the top 15% is here, and now we're actually looking for a data value, so we're going backwards. So we want to find the data value that puts you in the top 15%. So how do we do this? We're going to work backwards. So first of all, remember that our way our normal table A works, we're always looking to the shading on the left. That's what those proportion values are. So if you're at 0.15 and we know that the area has to equal 1, that means this is 0.85 or 1 minus 0.15, right? That's the area here. So we're trying to find what z-score, because you have to start off with z-scores first, because that's how table A works. So what value, and I'll just call it like this, because we don't know what to call it. So there's actually, let me put a number sign. So what number will give you a proportion of 0.85? Okay. So what we do is we go to the table, and we know that it has to be in the positive region because it has to, 0.85 is above 0.5, right? And 0 is like the 0.5 region. Anything above it is going to be closer to 0.85. So we look at the proportions now, and we want to find the closest proportion. So it's between the two of them. So is it the z-score 1.03 or is the z-score 1.04? So which is closer to 0.85, 0.8485 or 0.8508? Well, this is 15 away from 0.85, and this is only 8 away, so the z-score you would use is 1.04. So 1.04 is going to be the z-score, and now we plug into the formula, and we're going to solve for x. So here's our z-score formula. This is 1.04. X is what we want. We know the mean is 80, and we know the standard deviation is 7.7. You would cross multiply and solve, and the data value you end up getting is 87.931. Well, I hope this video helps, and I'll see you tomorrow.